For more Microsoft Webcasts, you can go to microsoft.com/webcasts. Once again, ladies and gentlemen, I would like to welcome you to our Msdn webcast entitled SQL Server 2005 Express Tips and Tricks. I would like to introduce today's presenter, Bill Graziano. Bill is a consultant for the Clear Data Consulting. Bill, you now have the floor.
Thank you. As Craig said, my name is Bill Graziano, and I'm a consultant with Clear Data Consulting. And I spend most of my day working with SQL Server developers and database administrators. And a lot of this presentation is wrapped around things that I find when I go and work with clients, and I kept seeing the same problems again and again and again. So this presentation is an attempt to try and identify these problems and hopefully help people write better applications for SQL Server. The agenda is really broken up into two pieces. We're going to look at things that apply just to the server and then things that apply to both the client and the server. So we'll start and talk a little bit about some of the tools for SQL Server Express. We'll talk a little bit about set-based processing and how that's different from procedural programming. We'll look at query plans. A lot of this presentation is time spent looking at different queries and how SQL Server interprets them. And for that, we'll look at an awful lot of query plans. We'll talk about some performance tips for the various queries. We'll talk a little bit about temporary tables and when you would or wouldn't use them. Then we'll start looking at things that apply to both the server and the client. So we'll look at how you connect to SQL Server. We'll look at how you handle the various data types on there. We'll talk about null values. Then we'll look at error handling and transactions at the end. So with SQL Server Express, the default download doesn't include, well, some of the default downloads don't include Books Online. I would really encourage you to go download Books Online. It's also updated regularly as features are changed or as they add documentation on various things. So it's a great download to have, and also check for updates regularly. I find a lot of developers write their queries in Visual Studio and one of the different flavors of Visual Studio. And what we're going to look at is the SQL Server Management Studio Express, which is nearly identical to the full-blown SQL Server Management Studio. And one of the big benefits that it has is it lets you look at the query plans for the queries, which is what we're going to do a lot of. It also does a very good job of, especially with Service Pack 2 installed, scripting objects. So if you create a stored procedure, you can very easily script that stored procedure out. It's also very good for just quick and dirty data browsing, just looking at a table, updating a single value in it. So let's start by talking a little bit about set-based processing. A lot of the languages you've been programming in, C# or VB or PHP or any one of the other ones, are all procedural languages. So you're telling the computer, in order, these are the steps you want to go through. SQL, and Microsoft's variation of it, Transact SQL or TSQL, is a declarative language. So you're telling the computer in a select statement, these are the rows I want, this is the order I want them in. And SQL Server is behind the scenes figuring out the best way to go get those values and present them to you. So a lot of performance tuning, and a lot of what we're going to talk about here is looking at what it's doing behind the scenes, how it's processing the queries, and how we can change the processing of that and better understand that. We'll also talk about set-based processing versus loops, and hopefully we'll point out the benefits of thinking in terms of letting SQL Server process sets of data for you rather than you writing loops, or in SQL Server there's something called a cursor that's basically a loop through a set of rows. And we'll look at how set-based processing is faster than using loops or cursors. So we're going to start by talking about query plans. In a couple of slides, we'll do a demo of a query plan. But a query plan is just the way that SQL Server processes a query. One of the things we'll talk about in there is the cost of a query. And the cost is kind of a made-up number that SQL Server assigns to it. And what it does is, behind the scenes, it compares a couple of different query plans and picks the one with the lowest cost. Now, the cost is composed of the CPU time and the disk time required to process that query. The key thing to remember is your query cost of the exact same query is going to be different on different computers with different speeds or numbers of CPUs and different speeds of disk drives. So when you're looking at query cost, keep in mind the number you're seeing is just relevant for that particular computer. So a number you see on a development machine might be different than a number you would see on a production server. So the first thing I want to talk about is correlated subqueries. And I think the easiest way to do this is I'm just going to jump down to the demo and start looking at this. What you're seeing here is SQL Server Management Studio. And I'm using a database called AdventureWorks. AdventureWorks is kind of a standard Microsoft demonstration database. And if you have SQL Server Express, it's a separate download available from the downloads section on the Microsoft SQL Server website. And all my examples that need data either build their own data or they use AdventureWorks. And I'll have these scripts available for download on my website at sqlteam.com later today after this presentation. So I do a little bit of setup on AdventureWorks. I need one index to make some of my examples work. So we'll run that. And let's start by looking at a simple query plan. One of the first things I do is set statistics IO on. You only want to do this when you're testing or evaluating the performance of a query. And when we run this, the statistics IO displays this message. For each table, it tells us the scan count and the logical reads. And the big thing that I want to pay attention to out of all these numbers is the logical reads. And logical reads is kind of a good predictor of how much disk access this is going to do. SQL Server stores all its data in 8K, 8 kilobyte database pages. And this logical reads tells me that SQL Server needed 2 reads of those 8K pages to process this query. The other thing that we're going to look at are execution plans. And there's a couple of different ways to see an execution plan for a query. So if I go highlight a select statement, I can hover over in the toolbar an option to display the estimated execution plan, and that will tell me what execution plan SQL Server thinks it's going to use for this query. I can also get to that through the menu. You'll see about midway down there's a display estimated execution plan, and then 2 down from that there's an entry for include actual execution plan, and I've got that checked. And for all our queries, we're going to look at the actual execution plan of our queries. And that's displayed in this tab. And these execution plans are read right to left. And these are just the steps SQL Server is going to go through to process this query. So the first thing it's going to do is what's called an index seek. And the biggest things that we're going to look for are index seeks, index scans, clustered index seeks, clustered index scans, and joins. And as we go through the demonstrations, we'll see more of these. So if you hover your mouse over the index seek or over any operation, you see a lot more detail about that. One thing to notice right in the middle of the rows at the top there where I can't move my mouse or it unhovers it, but it says estimated operator cost. And that's the cost that I was talking about for this. So the cost of this is 0.003. Down at the bottom, you'll also see a seek predicate. And that just tells you what value it's comparing to use this index. So for this index, it's an index on customer ID, and that's the value that it's using. Now, an index seek is the fastest way to go into an index. It's got an actual value, and it's going into seek on that value. We'll look a little bit later at index scans, and those are a much slower way because it has to scan a whole lot more of the table. The little arrow in the middle tells you how many rows go from each operation to the next. And then on the very left, the entire operation is select operation. The thing to notice here is there's a subtree cost, and that subtree cost sums up all the costs of all the operations all the way to the right. So when we look at the overall performance of a SQL statement, the first place I always look is at that subtree cost, and then I can see what the total is for that entire query. So that's a pretty simple query. It selects just the sales order ID out of the sales order header table. And because the sales order ID is the primary key of that, it doesn't even need to go to the actual table itself. If we make that just a little bit more complicated and we add a ship date to that, we execute it, we'll notice that our logical reads jumped up to 32. And if we look at why, we see that SQL Server now has to go look at not only the index seek that we saw before, where we're looking at this customer ID, and that's the where clause, the customer ID equals 344. But now we have to go look at the actual table itself, and that's the key lookup. So what this is doing, it's going to this index on customer ID, and it's using the sales order values that it finds in there to go look up in the actual table the actual orders, and then it's pulling back the ship dates for that. The other interesting thing to notice is that you'll see the cost is broken down in the percentage allocated to each step. So you'll see 17% of the cost goes to the index, and 83% of the cost goes to the key lookup. So as we start looking at the performance of these queries, we'll be able to identify which step in there is taking the most time. And the nested join is kind of a fake step when you're looking at an index and a key lookup. It's just saying that we're using the values we find in the index seek to go look up the values in the table, and that's the key lookup. So if we hover over the select statement, we see the total cost is now 0.01 or almost 0.02. Another interesting thing that you can do with SQL Server Management Studio is if you highlight two statements and execute those, your execution plan shows both of them. Not only that, but if you look at the first row of each query where it says query 1, it tells you of those two statements which has the most cost. So you can see the 14% in the first one and the 86% in the second one. So if you have multiple SQL statements, say in a stored procedure, you're trying to identify which one is spending all your time, you can very quickly do that. So let's look at correlated subqueries. This is what a correlated subquery looks like. And what this says is I have my simple select statement I started with, but I've added a quantity. What that's going is that's summing up the order quantity for sales order detail based on the sales order ID. And this is what makes it a correlated subquery, is that highlighted section. We're referring to the outer table, the sales order header table, in the subquery. And I see this written a lot. It's a pretty easy way to write a select that goes and pulls values from another table. And in this case, we'll look at it, and it's fairly efficient. You can see the sales order detail does 32 logical reads. Sales order header does 2 logical reads. If we look at the query plan, we see an index seek, which is the same index seek we've been seeing on the sales order header. We see a clustered index seek on sales order detail. It's getting a few more rows, but those are both index seeks. Now with the clustered index seek, it's going right at the value of the clustered index, which in this case you can see under seek predicates is that sales order ID. So the cost of 0.019, that's very similar to just doing a basic select out of the table itself. Now let's look at what happens if we add multiple columns. The thing to note here is that each of our 2 subselects or correlated subqueries has a different where clause in it. So when I run this, my execution plan now shows that I'm going to the sales order detail table twice. So keep in mind if you're writing correlated subqueries, if each one's a little bit different from the other, it's going to hit that same sales order detail multiple times. If we go look at our messages and your logical reads, because we're hitting that twice, we've now doubled our number of logical reads. The way to rewrite a correlated subquery with multiple columns is to use a join and a case statement. So we're going to join sales order header to sales order detail just like you always would when you're joining the 2 tables. And we're going to use a case statement, and we're going to check the special offer ID, which is what I had up here in my where clause in one of the columns. And if it's 1, then I'm going to sum order quantity. If it's 0, or if it's not 1, then I'm just going to sum 0. And that's going to exclude everything that isn't a 1. In my other column, I'm just going to sort. So if I run this, and let's just compare this to the other one, you'll see in the execution plan, the top is about 64% of the total, and in the bottom I get back to just a single pass through that sales order detail. So the takeaway for this is to be very careful about your correlated subqueries, and wherever you can, replace them with a join and a case statement. I'm going to take a... So one of the questions was, can you join tables from two databases on the same SQL server? And the answer is yes, you can. What you just need to do is prefix the name of the table with the database name, dot the owner name, dot the table name. So the other piece that I want to show with this is the not in clause. The other piece that I want to show after this is functions in a where clause. And I see this one used an awful lot, especially in date processing. You need to be really careful where and how you use functions in a date clause, specific functions in a where clause. Specifically, if you put a function around a column in a where clause, you'll typically prevent SQL Server from using an index on that column. And we'll look at that. We'll look at that in the demo. The other thing to be careful with is a not in clause. When you have an equal value or an in clause, SQL Server has specific values and it can go right at those values in the index. When you do a not in or a not equal, in many cases it has to go look at the entire index to find every value that doesn't equal those. The other thing that you can do that's pretty neat is if you're checking if rows exist for a certain condition. I see a lot of people writing like a select count and then checking that count result. And a much faster way is to use the exist statement. And we'll look at that in the demo also and talk about why that's faster. So let's look at a demo of the functions in a where clause and the exists statement. So here I have two queries. They both select the exact same thing. They both get all the sales orders from July of 2003. The top one uses a function year and month around the order date. The bottom one uses a between clause. So if I run these, let's start by looking at the execution plan. You can see there's a pretty big difference in these. The top one with the function around the columns uses about 20 times the resources of the bottom one, which compares a column to a scalar value. The top one you'll see is doing an index scan. And basically an index scan means that it's going to go through that entire index to find those values. Whereas the bottom one's doing an index seek, and it has a range of values, the greater than and the less than, or the between in this case. So it's going right at those values to get the results. So if we look at the messages, you see the top one does 61 reads, and the bottom one does 3 logical reads. So you get about, again, 20 to 1 in terms of the reduction of logical reads from your query. Now in dates, you oftentimes have to do some processing if you want, for example, just today's results, and you have the time embedded in there. You often have to do like a start and an end date. You have to do some processing ahead of time. You're almost always faster to do that processing and compare your date to a scalar value than you are to try and convert a column to varchar, convert it back to date time to get rid of the time. So the key takeaway from this is never wrap a function around a column unless you don't have any other options. The next thing I want to show you here is the exists. And I see a lot of queries written like I have highlighted here. If they want to know if there are any entries in the sales order header table that have status of 5, they count the rows, and if they're more than 0, if there are any, then they print found. Now the exists function down below is a much faster way to do that. What you can just say is if exists, and then the parameter of the function is just a select statement. And if that select statement returns any rows at all, then that exists evaluates to true. So if we look at the query plan of these, we'll see we get something like 100 to 1. Now notice they both do a clustered index scan. The cost of this one is 0.003. The cost of the one with the count is a 0.5. Even though they're both doing a clustered index scan, one is much faster than the other. And the reason that is because the exists will short circuit the result. Once it finds one row that matches that, it'll stop processing and return a true, whereas that count has to go process all the rows to find it. So when you use an exists, you're going to short circuit that result, and you'll typically get a result back much, much quicker. If we go look at the logical reads from that, we'll see that again, counting all the rows took 700 logical reads, where it only took 3 reads to find the first row where that was true. I'm going to go look at the questions here real quick. So question of what is logical reads when we set statistics I/O on? So logical read is how many reads of an 8K data page SQL Server is going to do. SQL Server stores everything in an 8K data page. And typically logical reads is a pretty good predictor of how many physical reads SQL Server is going to need to do that. And disk operations are usually one of the slowest things that SQL Server can do. So anything you can do to minimize the number of logical reads will help you minimize the number of physical reads, will help your application perform faster. The next thing I want to talk about is loops. The way to write a loop in SQL Server is to either use a cursor or a while loop. And in the demo, I'll show you an example of both of these. And typically, you only need to use these if you want to process one row at a time. And the most common example of that is if you have a stored procedure written. Let's say you have one written that processes a single order, and you need to call that for 10 orders. Well, you could write a loop that just called that 10 times and process it for each order. If you're doing that an awful lot, you'll find it's much faster to write something that processes all those rows or processes 10 orders at a time rather than processing each one at a time. If you're just doing it now and then it's not bad. So we'll look at some examples of that and how that works in a second. The other thing to know is that you can do a read-only cursor, which is much faster than a regular cursor, and I'll show you an example of that. And then a while loop is actually the slowest way to loop through SQL Server if your while loop includes a query to find the next record. So let's look at examples of loops. So my examples here are a little simple, but I want to restrict any other performance out and just show you the performance of the loop itself. So what we're going to do is we're going to simulate this basic select statement where I'm just going to sum the quantity times the unit price for a given sales order. So if I run just this statement, I get a nice clustered index seek. My total cost for that is 0.003. My logical reads is 4. So that's kind of our baseline for as fast as we can possibly do this. Now that went through and summed up, I don't know, 10 or 12 records in there and did it in 4 logical reads. The next thing we're going to talk about is a plain cursor. And that's what you see on the screen here is a plain cursor. You declare the select statement, and then you use the fetch next to loop through each row. And all I'm doing inside that then is setting the orders to the new amount. So I'm adding in the amount that I selected to the order amount. Now if I run this, now look at the execution plan, you see a whole list of statements there. What has to happen if you do a non-read-only cursor is that this cursor responds to any rows that are added during the processing of the cursor. So it basically has to, for each time through the loop, recheck the query and see if any rows were added. So you see just, I don't know, a dozen or so select statements all in there that are all pretty much identical. And if you look at the logical reads, each time through there you see that it's doing 3 logical reads on the sales order detail. I'm sorry, 1 on sales order detail and 2 on the work table. So about 3 logical reads per loop through there. So there's, I think 60, there's 120 rows in there, so 60 combinations. So you're looking at maybe 180 logical reads total to process the exact same result when you use a full cursor. Now, if you use a read-only cursor, and the only thing you have to do to make it read-only is to add that clause right there. And that makes the cursor read-only. Now, what this says is when that select statement runs the first time, it's got all the rows it needs. It's not going to go back to the table itself and check them. So let's look how this one runs. If we look at our execution plan, and we still see an awful lot of clustered index seeks. But we also look at the messages, and we see our logical reads went way down. We're now down to about 60 logical reads. Again, keep in mind we're comparing that to 4, which was the initial select statement. So let's compare that to a while loop. Now, a while loop just says we're first going to select the first value we need, and then while we're still getting values, we're going to add the total and then select the next value. The problem with this is it just runs an awful lot of select statements. In fact, you'll see its performance is nearly identical to a non-read-only cursor. The disk reads are identical to a non-read-only cursor. So you got about 180 disk reads or so. So the big point that I want to take away from there is that any kind of loop in SQL Server that involves selecting data is going to be slower than writing something that can process all the rows in a single statement. So if you want to update the order status of 10 orders, find a way to write an update statement that does all 10 at once rather than updating 10 individual rows. And let's look at some questions. So, and this is a very good question. It says that logical reads are a good predictor of physical reads. And the question was, is that because SQL Server doesn't provide information about a physical read? The problem with SQL Server is that it's caching that data into RAM. And if 2 or 3 queries are always running or requesting information at the same time, it might not be clear which query actually generated the physical read. SQL Server actually gives you very good information about how many logical reads the server as a whole is doing. It's just much more difficult to map back to an individual query and say, this query caused this physical read. The other problem with that is that the physical read really depends on what's already cached in memory. So you can test that by running a large select on a table and then running it a second time. You'll typically see the second time it runs much, much faster because that data is already cached in memory. So now I want to turn around and start talking a little bit about things that affect both the client and the server. And let's start by talking about how you connect to SQL Server. Wherever you can, if you're writing an application that's just using SQL Server, you want to use the SQL client namespace. It's a little faster and has some features that are specific to SQL Server in it. Connection pooling is on by default, and you want to leave that on unless you have a specific reason to not use that. The other thing that I encourage people to do is to set the application name in the connection string. And we'll look at some examples of that here in a minute. What you set in that application string, if you're having performance problems or you're not sure what's running a query, you can go look at SQL Server, and it will tell you what the application name is of the various connections. So if you have multiple different applications that connect to one database, for example, you've got a website and maybe another little application that does management or something that sends out updates, you can tell for each statement which application it came from. The only downside is that connection pooling is based on a unique connection string. So you'll create an extra connection pool per application, but each connection pool should be smaller. And I found an awful lot of help in using application name to troubleshoot applications, and I haven't seen any performance problems from having too many connection pools yet. So I'd really encourage you to do that if you have multiple applications connecting to SQL Server. The other thing I'd point out is that a SQL data reader, which is basically like a read-only cursor on the client, is typically much faster than bringing data down through a data table. So if we look at setting the application name in your code, there's really 2 ways to do that. If you use the connection string builder, you can set that application name property there, and you can see that's the line I have highlighted in yellow. If you're just building a straight connection string, you can see they're just setting the application name entry there to my demo app. So I want to talk about nulls a little bit, and nulls are kind of an interesting database concept. And what nulls are an unknown value. There's a standard setting body called ANSI that has a standard called SQL92, and they've defined some standards for how nulls should be handled. So all the various databases that conform to SQL92 should all handle nulls the same way. And what that requires is any comparison to a null is always false. Any comparison to a known value of a known value to an unknown value should always fail. And SQL Server has an option that you can set to enable or disable that. And the default setting is on, which is the ANSI nulls on. So if you compare null to null, that will always return a false. And if you compare null to not equal to null, that will also return a false. Now you can turn ANSI nulls off, and that will have a null equal null return true. However, I would really encourage you to leave ANSI nulls on. So how do you compare to a null? Well, you use the isNull predicate. So you say where column name is null. So avoid the where column name is null equals null. The other thing to avoid is there's a function called coalesce, and that returns the first non-null value that it finds. So you can see there in that second bullet point, I'm comparing my column to the coalesce of a variable or a column. And what you think might happen is that if there's a value there, it'll use that value and compare the column to the value. If there's no value, if that variable is null, it'll compare the column to itself and basically just ignore that comparison. The problem is in that sample, you've now wrapped a function around the column, and SQL Server won't use an index for that. And the same thing happens below in the isNull or column equals at variable. So let's look at an example of some uses of null. So we've seen a straight select statement, and we've looked at the query plan for this, and it's basically what we're expecting to see. We've got a clustered index seek, so we're going at the clustered index with a scalar value, and that's about as fast a query as we're going to write. So let's look at this now where we use the coalesce function. So in this case, I set sales order, I declare a variable sales order ID, I set its value, and the only difference I've made is I've wrapped this coalesce function around the value in the column. However, when I run this, I now get a clustered index scan, and I didn't look at run these both together so you can see the comparison of them. So you see about 100 to 1 performance decrease by wrapping that coalesce function around there. My logical reads goes from 3 to 700. So it's much, much slower to wrap a coalesce around that. Now if we use sales order ID equal the variable, or if the variable is null, unfortunately that doesn't work any better. We still get 700 reads, and we still get a clustered index scan. So if you do want to have conditional parameters, and probably one of the more common uses for null and variables is conditional parameters, especially for reporting, you have to do some dynamic SQL. So if you look at the SQL that I have here on the screen, you'll see I declared two variables, a sales order ID and a sales order date. And I set the sales order date to null. Then I just start building a select statement. And on lines 275 and 278, I check if those parameters are true, if those parameters have a value, then include the parameters in the where clause. And then on line 283, I use the SP execute statement. And the first parameter is a SQL statement that I built. And then the next parameter is a comma-separated list of the parameters in the SQL. So you see that at sales order ID and at sales order date are both in there with an integer and a date time. And then I include the actual values. Keep in mind this works even if you don't use the variables in the SQL statement. So in my example here, I'm going to run it without even passing it a sales order date, and it will still work. And when we run this, we get a nice clustered index seek with our 3 logical reads. So if you're going to do conditional parameters in reports, that's the way you need to do it. My other example is just doing this using a combination of the ORs and the coalesce. And I actually need to run all of this. And again, you get a clustered index scan when you wrap that coalesce function around the column. So let's move ahead and let's talk a little bit about storing, bringing SQL data down to the client and how you would store that. Specifically, a lot of this is related to the null value. So the basic data types, and my examples are all C#. The basic data types don't handle null. The VB data types don't handle null either, as far as I know. In the SQL data reader, there's a property called isDbNull, and you can pass that a column name, and that will check whether or not that column is null. If it is, then you can put a holding value or something in your variable. If you do put your data in a data table, the data column itself has an allowDbNull property that you can set to allow nulls to go in there. And if you're using SQL parameters to call stored procedures or to execute SQL statements, you can use the system.dbnull.value to assign a null to that or to check if that has null. Now in ASP.NET or in .NET 2.0, they added nullable data types. That's the int question mark, string question mark to handle null. And those do handle nulls. However, I'll show you an example in just a second of something we need to be aware of when we use those. The other option is to use the .NET SQL types, and these are just classes that are specifically designed to be as similar to SQL data types as possible. So you see the statement there that you declare a new SQL string, and you can check the isNull property of that string, and that will tell you it's true or false. You can assign it to SQLstring.null. The same works for SQLint, anything like that. There are methods in the SQL data reader specific to the SQL data type. So there's a get SQL string method, a get SQLint method, a get SQL datetime method. Typically, these aren't used as often as just straight data types. It's a little tougher on the client side to write code using these. You don't get as much of the IntelliSense, so I don't see these used all that much, especially with .NET 2.0 and the nullable data types. With these, you just declare a string, and you just string question mark. Now, the property to check for null is backwards of the way it is on the SQL type. Instead of checking isNull, you check has value, and that's either true or false. And then you can just assign that just a straight null value. Now, keep in mind that when you're querying out of a SQL data reader, you still need to check isDbNull. If you try and use just getString out of a data reader and put it into a nullable type, a nullable string, and it's null, it will generate an error. So you'll need to check isDbNull and then assign null to it. So let's move on and let's talk about error handling. New with SQL Server 2005 is the ability to consume an error on the server. Prior to this, you could just check a statement after it executed and see if it caused an error. We can do that through a try-catch block, and it's also possible to nest try-catch blocks. So in your catch block, you could nest another try-catch block if you want. The other thing that I'm going to encourage you to do is to not add error handling where you don't need it. So anywhere that it's possible, if you're going to do an insert and a row may already be there, use that exist function to check if those rows exist. And anywhere that you can capture the error, then, say in a stored procedure, you can use a return code of that stored procedure to signify that it failed. So let's look at some examples of error handling. So my examples here all use tempdb. We're just going to start with a simple divide by zero error. So when I run that, I get my nice divide by zero error, error number 8134, on line 1, level 16. Now if I embed this in a try-catch, and that looks something like lines 7 through 19, I got a number of functions that I can use to give me information back about that error. So when I run this, I don't actually see an error, but I can get all the information back about that error. There's that error number 8134, there's the divide by zero, and then I could decide what I want to do. And you can put any number of statements you want inside that try. So I just have just a simple select, but I could have selects, updates, or whatever else I wanted in there. It also told me what line that occurred on. So that was, again, the second line of that batch is where that error occurred. So if you have a multiple line SQL statement or multiple batches in there, you can see where that occurred. Now it gets a little more complicated when we put this in a stored procedure, so let's look at how that works. So I've got a simple stored procedure that I'm going to create called make an error. And that just takes a parameter on line 29 called handle error, and all the handle error says is if I don't handle the error, I just divide 1 by 0. If I do handle the error, then I do the try-catch inside the stored procedure. So let's create that. And then let's use it. So if we call it and tell it not to handle the error, I don't get an error, but I get the result of that is that it was line, or is that it was the same error, 8134. It also gives me the name of the procedure. It was make an error, and it gives me the line number there. So if I start counting down from the very first create procedure statement on the 18th line, that's where I get to that 1 divided by 0. Now I can also change this so that it will handle it. In that case, it just gets captured in that stored procedure. Now, if you nest these, and I've got a nested stored procedure here, that all it really does is just call make an error with the parameter telling it to not handle it. We'll make sure that's created. Then when we run this, now, if you look at this stored procedure I have, and I'm going to change my window size so you can see this a little bit better, you'll see that what it does is it calls this make an error inside a begin try and end try. And it checks, was the error number 5? If so, it captures it, but it wasn't. So what it does is it comes down and it captures out the error message, severity, and the state from that, and uses the raise error command to re-raise this error. So with that, you can write some pretty sophisticated error handling routines inside SQL Server to just capture certain errors and let certain errors get passed back. Now what I'm going to do is uncomment that line so that it just runs make an error right away and causes an error. And with that, I want to show you inside a nested error, it found the right procedure name even though it was one level deep in what was calling. So the error handling is really pretty good to figure out if you have procedures that call procedures that call procedures. It'll tell you which procedure had the error and what line that error was on. So let's look a little bit at handling errors on the client side. So what you need to do on the client side is also a try-catch, and you want to catch a SQL exception. You can see my little code there captures the SQL exception, and there's a properties for the message, for the error number, severity, and all the standard things you see with a SQL Server error. The other thing that's interesting there is there's also a property called errors, and if more than one error occurred in your SQL statement, that errors will have each of those errors in it. So the main properties, message and error number, we populated with the first error, and then all the rest will be handled in the errors collection. So keep in mind if you're starting to write some advanced error handling, keep in mind there may be multiple SQL errors that could have occurred there. So one of the questions was, what impact does SQL error handling have on performance? The error handling, if no error. If no error occurs, it's very, very minimal. The impact performance, if an error does occur, there is some overhead. I don't have a good feel for that. It's not horrible, but it's certainly not as fast as just straight code. So let's move on. This is my last major topic, and this is transactions. And this is a pretty interesting one. It's also kind of complicated. My demos on this are kind of interesting to wade through. So in a transaction, you do a begin transaction. You do, let's say, 2 update statements and a commit transaction. And what SQL Server guarantees is that anything that executes inside a begin and a commit transaction, either both statements will be done or neither statement will be done. So a commit transaction matches a begin transaction and commits that transaction. If you don't want to commit that transaction, if an error occurs, you can issue a rollback transaction. And that's going to cancel all open transactions. So we're going to look at in our demos of nested transactions and how a rollback transaction cancels all nested transactions. So the takeaway from this is that always make sure you begin, commit, and rollback transactions at a consistent level. And that'll be pretty obvious in the demo. We'll look at both just straight SQL, and then we'll look at it through a stored procedure. The other thing that you can do to make your life a little easier here is there's a property called tran count, and that tells you how many transactions are currently open. So tran count is 0 if you're not in a transaction. As soon as you issue a begin transaction count goes up to 1. Another begin transaction count goes up to 2. A commit tran brings it down to 1. Another commit tran brings it down to 0. So tran count can tell you if you're in the middle of a transaction and are there any open transactions. So let's look at this demonstration. So I'm going to do a little cleanup, make sure I don't have any open transactions. I'm going to create a table called tran1, and all I'm going to do is do some inserts into this transaction table, roll some of them back, and then see what's left over in that table. So let's create this table. Here's my first example. Now all 4 of my examples here are pretty consistent. You'll see on line 22 I begin a transaction, then on the next line I insert a value. Line 25, I begin a nested transaction. Line 26, I insert the value 2. Line 28, I commit the inside transaction. Line 32, I commit the outside transaction. And on line 36, I select the detail, and then the delete is just to clean up for my next example. So when I run this, and then all through there, I'm going to print the tran counts. So when I run this, I start at tran count 0. I insert the values, and the innermost tran count is 2. Then it goes back to 1. Then it goes back to 0. And then I have 2 values in V1. So it did just what I thought it should do. It left there with 2 values in. Now let's look at a rollback. Let's say we had an error in there we want to roll back. So I have my first transaction at 43, my next transaction at 46. In line 49, I roll back my inner transaction. At line 53, I roll back my outer transaction. So let's run that, and let's see what happens. So what you see is, I start with the innermost transaction of 2. Then as soon as that rollback occurs, remember that a rollback rolls back all open transactions for this connection. So the transaction count goes from 2 back to 0. So my second rollback tries to run, and there's no transaction there, and that generates an error. And the error is the rollback transaction has no corresponding begin transaction. So remember that a rollback rolls back any open transactions. So let's look at another example. So we have a begin on line 63, a begin on 66. On line 69, we commit the inside begin transaction. On line 73, we roll back the outer transaction. What does that leave us with? So we don't get any error this time. There's our inner transaction. There is our commit of the middle transaction. And then we roll back. But keep in mind that you'll see there's no rows in that table. That outer rollback transaction rolled back that inner committed transaction. So the key takeaway is that a transaction isn't really committed until all the nested transaction and its parents are committed. So until you commit back to tran count of 0, you really haven't committed, and a rollback will roll back any nested transactions. So for my next example, I have a stored procedure that we're going to use. And I need to go set it up first. So what this does is I have a table called tran test. It's defined right there on line 16. It's got a row number that's a primary key. And what I'm going to do is insert a first value into it, insert a second value into it, and then based on the error I get when I insert the same value a second time, we'll do different things with transactions and kind of show you how error handling and transactions interact. So my stored procedure looks pretty much like the scripts I had before. I start out by printing the transaction count. I begin the transaction. I reprint the transaction count. I have a try-catch on lines 34. If the insert goes in cleanly, I commit the transaction. If the insert fails, I roll back the transaction. So let's look at running this. Let's do our cleanup. All right, so when I run this script, I'm first going to call this on line 11 with a value of 1. So I'm going to insert 1. I'm going to check that return code. Then I'm going to call it again on line 25 with the exact same value of 1. That should cause an error in the stored procedure. Should cause it to roll back. And we'll see what kind of errors we get from this. So let me run this. So my first select, which is before the dash line, works just fine. My tran count when I get to the stored procedure is 1 because I started a transaction here on line 9. The next line you see in the results is the begin tran inside the stored procedure. It inserts the row, 1 row affected. It commits that transaction. The return statement is 0, just fine. The transaction count is 1 coming back. So after the dash line, I'm trying to reinsert the value 1. And you'll see it gets an error. Now that error was handled inside the stored procedure, so it rolled back that transaction. You notice you get 2 errors. The first error says that I went into a stored procedure with a tran count of 1. I came back out of it with a tran count of 0. So something happened inside that stored procedure that changed the tran count, something committed or rolled back, and that generates an error. So you'll need to make sure you commit and roll back transactions at a consistent level. And then when I go run my code, because I'm not checking tran count down here toward the bottom, that error on line 29 should check tran count, but it doesn't. So that causes my second error there that says the rollback transaction has no corresponding begin transaction. On the client side, if you want to do transactions, it's pretty straightforward to do. The lines in yellow are what you need to add to your standard pattern of how you access SQL Server. You create a new SQL transaction object, and the result of that is the begin transaction method, which is a method from the SQL connection. And one of the reasons to use the SQL client namespace is the transaction handling. So once you've got that transaction object, you apply that to the transaction property of your SQL command, and then in your try-catch and your try, you do a commit, and in your catch, if there's an error, you do a rollback, and then that's really all you need to do transactions from the client in .NET. So we talked an awful lot about reading query plans. Hopefully you have a better idea on how to identify the slow parts of a query and begin to look at those. We talked a little bit about loops and how you would try and prevent those. We talked about tips and tricks, not using functions in a where clause, handling nulls. We talked about how you would handle SQL data on the client. We talked a lot about error handling and how you can handle errors effectively inside SQL Server, and then transactions and what transactions are and how they work inside SQL Server. So I'm going to turn it back over to Craig to do a little administrative. Let me do one more slide here. So some key sources of information. The Microsoft SQL Server website is a great site. There's also an Msdn SQL Server Developer Center that has good information, as well as the TechNet SQL Server Tech Center. The Tech Center is more for administrators than developers, but still has good information. Three of the larger community sites. SQL Team is a site that I run. We have a very active forums. It's a great place to go ask questions. SQL Server Central and SQL Server Performance also have active forums. A great place to go ask questions and get help. And with that, I'm going to turn it back over to Craig for some housekeeping, and then I'm going to take questions for as long as I can.
All right, fantastic. Great presentation, Bill. Would like to share some additional resources with our MSDN crowd real quick. We will begin our question and answer session in just a minute here, but once again, feel free to go ahead and ask your question away. Go down to the bottom of your screen and type your question in next to the Ask button. Then simply click that Ask button. As I mentioned earlier, you can view a replay of today's live event, or you can register for some upcoming webcasts by going to www.microsoft.com/webcast. The streaming media replay and downloadable WMV file will be available within 24 hours. I am going to be providing a survey for today's event in just a moment, and I would like to encourage you to go ahead and take a minute to complete today's survey. The feedback and comments that you provide ultimately just allow us to create better webcasts for you. If you've got an idea for a webcast now, or you'd like to see some specific content developed, you can go ahead, point your web browser where I just pointed that arrow on your screen, and we at the webcast team will do all that we can to bring you a webcast of that content. Now today, by attending this live webcast, which you all have obviously done, and submitting the evaluation, which we will get into here in just seconds, you will be entered to win a 30 gigabyte Zoom digital media player. So just by taking a moment of your time out, you have an opportunity to win some pretty cool hardware today. Without further ado, here is that survey I have been mentioning. If you can, just go ahead and follow the links that are provided in your interface right now, and take a moment to go ahead and complete today's webcast evaluation. Again, your comments are very valuable to us. At this point, I will go ahead and hand the floor back to Bill so he can answer some of the questions that have come in. Bill?
Great, thanks. So the first question is about, what about authorization issues? How do you make the second table accept the connection to the first table? Same users are set up in ASP.NET-DB, but I can't seem to join to integrate new members to existing user information in a pre-existing table. So whether or not your client connection can log in to SQL Server and query a table is not affected in any way by the membership issues in SQL Server. If you want to make sure that a given username and password can log into SQL Server Express in the SQL Server Management Studio Express, you need to create a login with the password and then a user in that database, and then make sure that user has permissions granted for that. Next question, what optional functions can be downloaded and are not installed with the SQL Server Default Express installation? So there's a link there. When I just posted it, I think it just popped the question out. But that link, it compares the two editions of SQL Server Express. One is Advanced Services. I know one of the big changes, some of the big changes are reporting services and full text indexing, but that page should have details on which features are available in the different flavors of Express Edition. So the question is about logical reads. Not sure if this is one I've already answered. So if talks about if a query has more physical reads, then we need to change the query. So again, I would encourage you to focus on logical reads and not physical reads, because the logical reads will change each time you run the query. If you run it once, you'll typically see a lot of logical reads, a lot of physical reads. They'll probably match. If you run it the second time, you should see no physical reads and more logical reads. So the number of physical reads is very dependent on when you run the query and what else has run at that time. So the question is, back to your statement about using functions in a where clause, what is the optimum method to get all records where a date column is greater than a certain date? Is there a better way than where date column greater than date diff? And Craig, am I correct in assuming they can all see this question?
Yep, they should.
Okay, so in the example question there, it's where date column greater than date diff, get date. Now, in this example, you're actually comparing the date column to a scalar value. The scalar value is just the result of a function. So it's okay to use a function as long as that function just operates on variables or like the get date function. So if your date diff is just, subtracting one day from get date, you're just fine. You're comparing the date column to a single value. So that example will work just fine. So the question is it possible to get the connection string from web.config when using the SQL client and OLADB client? If yes, how? You actually get the connection string before you start using the SQL client. I cannot remember the exact syntax off the top of my head, but you use the configuration, I think it's a configuration namespace. That'd probably be a good thing to go search for. Already talked about error handling. The question is, can you perform transactions in a loop? If somewhere in the loop the transaction fails, do all the previously inserted records get rolled back as well, or just the records that failed? So really, whether you're in a loop or not in a loop has no impact on it. All SQL Server sees is a sequence of begin transactions and commit transactions. So let's say you're in a loop, and inside that loop you just have, and you loop through 10 times, and you have 10 begins, 10 commits. So if you go through 8 times and you do 10 begins and 10 commits, those 10 are committed. And the ninth, when you do a rollback, you're not going to roll back the first 8. Now, if you do a begin transaction before the loop starts, and then inside the loop you do a rollback, that's going to roll back all those transactions. So it really depends more on where you begin and end a transaction for that. Yes, my SQL scripts will be available for download. It's lunchtime where I am, so I'll probably eat and then put them out there. But there'll be a link on SQLteam.com with this presentation. I'll put the PowerPoint and my scripts in. I specifically wrote the scripts using AdventureWorks, so hopefully you guys can work with them, try them out, see what works, see what doesn't, and build on them and learn from them. Next question, do I have any tips for setting up indexes? So each table should have a primary key, which should be a clustered index. What I really focus then are indexes on things you use a lot in the where clause or on things you join to other tables. And I'll typically find that, you'll have a pretty good idea of which, say, you want to filter by dates. Those are good columns for indexes. If you have columns that you join on other tables to, for example, let's say for your sales you have a category ID. That might be a good example, a good place to put an index. One of the things that you can do is using a query plan, you can write a query that you think is running slow, put the index on, see if it runs faster, see if it uses it in the query plan, and then take it off. And that's a lot of what I do in performance tuning, is putting on indexes and see if queries use them. So can you provide detail regarding comment about efficiency of a SQL data reader versus a data table? I know that if you search on Msdn, somewhere there's an article comparing the two of them. I know there are performance improvements in the data table in .NET 2.0, so I don't know how accurate that article still is. I haven't seen an updated article since then, but I would start with looking through Msdn. I think if you just search on SQL Data Reader and Data Table, you'll probably get pretty close to it. It was written by a third party, somebody out in the community. So the question was, in stored procedures, you say use dynamic query, which has to recompile the stored procedure. How does this compare with a logical read when doing additional parameters? So I assume you're asking, are more parameters worse than fewer parameters? And the number of parameters really doesn't matter because I'm building up the entire statement before I issue it. The number of parameters really doesn't affect the stored procedure. And if I didn't get your question right, you might try and rephrase it and put it back in, and I'll get to it. Installed SQL Express in conjunction with Visual Basic 2005 Express on Vista. It wanted IIS 6, which is for XP. Any ideas? I would check and make sure there's a Service Pack 2 version of SQL Server Express that plays a lot better with Vista. You might get better results with that. I know that SQL Server has buried in it some things that use IIS. I haven't used those much with SQL Express, so I don't know if they're enabled or not. I would try the SP2 and see if you get better luck with that.
All right, we have actually run out of time. So if I can have you answer
I have one more question.
Okay, go ahead.
Are there any good examples of a SQL command utility? I have an old app that uses OSQL against MSDE that I need to upgrade. My best thought for that would be to go search it. You might find some articles out there. I think there's a few that have been written.
All right, fantastic. Well, then I would like to extend a special thank you to Bill for his presentation today. I would also like to thank everyone for attending today's webcast. Ladies and gentlemen, that is going to conclude our Msdn webcast for this morning or afternoon, I guess, depending on where you're calling from. Thank you for joining us, and we look forward to seeing you again soon. You may now disconnect from the audio portion of this conference.